Hello friends, I welcome you in lecture number 40 on higher order ordinary differential equations. In previous lecture we have discussed about method of reduction of order, and we have seen that if we are given one solution of differential equation of second order, then we can obtain the second solution using this formula y2 equal to y1 times e raised to minus integral of p with respect to x divided by square of y1 and integral of this quantity with respect to x. In this lecture also we will discuss this question on the method of reduction of order which was asked in GTU Winter 2022 exam. Here we are given that y1 equal to e raised to minus x is one of the solutions of this homogeneous linear differential equation, and using this solution we have to find the second solution. So first we can see that solution given is y1 equal to e raised to minus x, and it is solution of the differential equation y double dash plus 2y dash plus y equal to 0, and we give this number 1. This is given information, and to apply the formula of method of reduction of order, we compare given equation with the standard form of homogeneous linear differential equation of second order y double dash plus px into y dash plus qx into y equal to 0, and we have px is equal to 2. Px means coefficient of y dash, which is 2 here. And now we can write down the formula for second solution using the method of reduction of order. The second solution is, we denote second solution by y2, and it is given by y1 times integral of, here we write y1 square e to the power minus integral of px with respect to x, and whatever we obtain after doing this division we have to integrate that quantity with respect to x again. Now this is equal to y1 times e to the power minus integral of px. Px is 2, so here I write px equal to 2 dx y1 square integral with respect to x, and y1 is given, we can put value of y1 also simultaneously. Y1 is e raised to minus x, and we have square of y1, that is going to be e raised to minus 2x, and y1 is e raised to minus x, and we have to simplify this first, and this is equal to e raised to minus x integral of this 2 with respect to x is 2 into x, that is e raised to minus 2x divided by e raised to minus 2x integral with respect to x. E raised to minus 2x will get cancelled, and here we have 1 with respect to x, this will get cancelled, and integral of 1 is x, and finally our second solution is x times e raised to minus x using the method of reduction of order. So this is very easy question, and it was asked in GTU Winter 2022 exam. Now you can observe that this is homogeneous linear ordinary differential equation with constant coefficients. So we can check our solution by finding the general solution of this equation. So we cross check our answer. We know how to solve the homogeneous linear differential equation with constant coefficients. So this is just for verification. Our equation is y double dash plus 2y dash plus y equal to 0. This is just for remark that whether our solutions are same or not. So we first write down the auxiliary equation, which is lambda square plus 2 lambda plus 1 equal to 0, and this is nothing but square of lambda plus 1. That is, we have lambda equal to -1 repeated, and we know that if we have equal and real roots, the general solution is given by y equal to c1 times. If we take lambda equal to -1, we have e raised to minus x plus c2 times e raised to minus x, and because these two are dependent, we multiply by x, and we observe that two solutions are y1 equal to e raised to minus x and y2 is x e raised to minus x, and in our question they have given this solution. y1 equal to e raised to minus x is given, and we obtain y2 equal to x e raised to minus x using the method of reduction of order. So if they specify the method, then you must go using this formula, and if you are going using this formula, even if it is not specified the method, then also there will not be any problem. But this formula will be helpful if you have an ordinary differential equation with variable coefficients. We have the topic of series solutions for the solution of differential equations with variable coefficients, and in that topic also we are going to use this formula to find out the second solution if one solution is obtained using that power series method. And for this session this is enough. We have discussed this question on the method of reduction of order, which was asked in GTU Winter 2022 exam. So this is all about this session. I hope you like it. Thanks for watching.